Okay, hello and welcome to another webinar by Komodor. We'll just wait a couple of minutes to let everyone join in, and then we'll start the conversation. Welcome Sergio, Subash, Sunita, Prashant, Prasad, Osher, Phil Edwards, Mohini, Mikhail, Ashish, Rune. Welcome, Raphael and Robert. You see we have some returning guests here. All right, let's kick it off, Andrei. Itiel,
Let's go.
Okay, so welcome again to our webinar on Kubernetes and GenAI, topic that's been talked a lot about, and you hear it everywhere, but we have an interesting angle to discuss today. We just recently launched Claudia AI, our advanced troubleshooting agent for Kubernetes.
Yeah, it's actually our first experiment, or not experiment, but the product at that scale of application of AI. This is when we got really serious. So this is why it's a bit special for us. Before that, we didn't invest that much into AI because we were cooking it in our lab. And now, after we released it, it's a special occasion for us, and we are glad to speak finally after so many months of silence to speak about it.
Yeah, and speaking of our lab, we have here the two mad scientists behind this project. With me here, I'm lucky to share this space with Andrei, who came all the way from Portugal, just for this live webinar. And Andrei has a history of contributing to open source, leading open source project. He's the brain behind Helm Dashboard and Plane, are popular open source projects. And also Claudia now that we will discuss. And Itiel is Komodor's co-founding CTO, used to be a developer turned DevOps, saw everything from small startups to large-scale enterprises. And Itiel is not with us here physically, but we do have his image here with us. So
yeah, happy to be here.
Before we get started, I just want to thank everyone for joining in. If you have any questions, feel free to drop them in the chat below, and we'll address them as we go on. Everything will be recorded, and we will share the recording and any other materials and links with you after the webinar. All right, so...
and Udi will moderate this session for us
yes.
And lead the conversation.
I will do my best. And yes, I'm Udi. I'm the developer at Komodor, and we also have with us Nikki behind the scenes, taking care of everything that you cannot see and some things that you will see. So let's get right into it. So Itiel, Andrei, when did you first start paying attention to AI or Gen AI? Because it's been a thing for a while, but
yeah, I think that we looked at AI even when we started the company. So ever since founding Komodor, AI was always there, mainly because AI always sounded like the most logical thing to do. Like in IT, you have a lot of data, right, and a lot of repetitive work. So using AI in order to solve it makes total sense. When we started the company, we took a decision not to use AI mainly because we felt it is like overselling and under delivering. In the end, AI solutions were not that great in helping solve DevOps issues. We resurfaced our interest in AI when basically like OpenAI became popular and Copilot. So this was actually like a turning point when it comes to, can we actually use AI in order to make our life easier and our customers' life easier? So I think OpenAI was the main thing that like changed the picture for us.
And I know you were skeptic at first, Andrei. So when did it shift for you? So I remember you didn't see immediate value. You thought maybe it's just a buzzword or a phase or it's all hype. When did it change for you?
Yeah, this is true that I'm very skeptical to all of these hypey things, but I'm also not stupid. So I'm seeing what people talk about AI, and my skepticism needs to just go and investigate. And for me too, it was the changing point, the ChatGPT thing, when they made it freely available to interact with that agent, and I started to experiment to see how smart is that thing. I still think that thing is not too smart, but I understand the technology behind it, and I understand that this technology is really advanced, massive, and the value it can replace search engine for me, because the amount of knowledge that it contains in this intelligent blob is impressive. It basically replaces the search with smart search features. Because I used to work for the search company, and I know that how hard the search companies try to make their search intelligent and context aware, and they didn't do it through all of the years. And ChatGPT is that thing. So this is how it changed for me. I still underappreciate the coding copilots because they interfere with what I write, but maybe my code is not standard, so I'm more used to just writing my code without any suggestions, especially suboptimal suggestions. But yeah, and probably after we did Claudia, I'm finally convinced that this tool of AI can be used to really build something that will be game-changing in the market. And we are just scratching the surface of that. So I'm excited about the future of AI and future of the products that use AI.
And what, in your opinion, where do you still see a diff? Because there is still a lot of, there's now value emerging, but there's also a lot of fluff around it. So where do you see the diff between the big promises of AI and where we are in actuality?
That's actually a big pain point, and this is part of me when my skepticism says, yes, this is all wrong. But no, AI as a technology, I am sure it's worth the hype. The problem is that when companies rush to just put the checkbox, we have AI, without actually focusing on the real value. This is why it took us so long to bring our AI-related product, because we wanted to not be that just checkbox marked. It's very easy to put some stupid wrapper around the chatbot and still have the same chatbot, and then the user is left with that chatbot at its own disposal. Not much value added on top of language model. So this is how you can recognize the hype or marketing gimmick as opposed to the real product, is when the wrapper is very thin and the goals are very broad. It's like it would find you everything that you don't even know and would do everything for you, but you need to chat with it for 1.5 hours and explain it well what you want. So this is when I smell something bad is happening.
But isn't it like an hour and a half less than what you would need to invest in explaining a task to a human developer?
Something like that.
Itiel, what do you think?
Um,
Where do you see
on,
the gap between the big promises and the actual
yeah.
potential?
I do see like a question by some of the audience, so I'll answer it like real quick. Like we are going to share some slides on how did we build Claudia, as well as a live demo of the product, like in reality. So stay tuned. Like I'm not sure how to pronounce the name. I think that the biggest diff is that I use Copilot. I'm happy with Copilot. So that's like my experience. And I also use Claude and OpenAI quite a lot. So this is quite great. But on the other hand, both Claude and like OpenAI and Copilot, you have a human in the middle. Like you're in the middle, you can ask it question, you can improve your answers. And it's one thing to build the tool that knows that a human is always going to review it. When we build the Claudia, we try to have no human in the loop, meaning that a human is not expected to interact with the AI. And this is a very challenging thing. Most companies, most AI products are trying to build this thing that will be like a magical thing that like doesn't require any interaction. And to do that, you need something a bit unique. In Komodor, our uniqueness is a very large set of data that is unique to us, as well as our Kubernetes experience, as well as the fact that we built Claudia to a very specific thing. It does only troubleshooting only on Kubernetes. And I think that you need one of the two, like a man in the middle, right? And or something very narrow scope so it will work out of the box.
And what other ideas are you hearing from the field? Various applications for GenAI and use cases that you haven't dreamed of yourself?
I think there's a lot of interesting things like GenAI for test generation, like a load testing, GenAI for.
You had a spot with Andrei, who, if you don't know, was a huge part of BlazeMeter at the time.
Mm-hmm.
Yeah, but the previous startup we was doing exactly the test generation. That's a pain point for me, and it's something that I would like to take some rest from that theme of testing. I know for me, what drives me right now is the fact that we can use AI not as just a generator, but more of an agent, the smart agent that can do things or guide things. And this pattern interests me the most because this is where I see how the things we do with AI, this is when it becomes more than just a chatbot, because the pattern that has crowded the market is the pattern of I'm sending some question to AI. This question is accompanied with some data, and then the AI gives me the response based on the data and my question, as opposed to really unleashing the AI and giving it some goal and asking it to achieve that goal, whatever that means. If that means to interact with chat, let it interact with chat, but really be more goal-oriented or task-oriented, target-oriented, as opposed to be chat-oriented. This is, in my opinion, the big shift in approach when you stop seeing the chatbot and you start seeing some brain that only lacks eyes. So you need to provide eyes, and it lacks hands or legs. So you need to provide the hands and legs, but the brain is already there. So this is how I look at AI, at these language models, at least right now. It's pleasant to chat with ChatGPT, but I feel we can do a lot more with it if we give it eyes and hands.
That's an interesting notion. Marshall McLuhan said back in the 70s, I think he said that humans are the reproductive organs of the machine world. And now you're saying this is exactly what we are.
That's smart.
Or maybe not even a productive org, it's just the limbs and eyes. Okay, let's bring it back to our world. So we talk a lot about the skill and knowledge gap between SREs, DevOps, platform engineers, and application teams or developers. How can GenAI help bridge that gap? And what potential is there for GenAI and the world of Kubernetes that has numerous challenges? The knowledge gap is just one of them.
Let's hear what Itiel says, because he's much more experienced in that than me.
I think the promise is always to have this like AI assistant that will do everything for you, right? Like it's true for DevOps, it's true for like home assignments, it's true for everything. Like how can we automate the boring, like non-creative stuff, basically. And when it comes to platform versus developer, we're already starting at like the very bottom. And in this case, it's like developer doing troubleshooting, right? And because when DevOps are doing troubleshooting, it's a very complex like situation a lot of the times. It's a combination of I have a problem with the ingress and with the PVC and with the nodes and so on. So it will be quite hard to automate that. On the other side, when we're looking at the tasks that developers are doing when it comes to troubleshooting, a lot of the times it's much more simple. Like you go, you see what changed, because most issues originate from changes. Then you read the logs, you read the events, and you do a revert or increased limits or something like that. That is the honest like work of developers troubleshooting Kubernetes. So currently, even that it's quite hard for developers. What I just said also required expertise, experience, access, and so on. What we're trying to do is like looking at this pyramid of what our developers are expected to do, what are currently DevOps and SRE are doing. We want to start to automate each part of the way, meaning the ability to tell both the developer and the DevOps, like your life doesn't need to be that hard. We will take some parts that are very hard for you, but we can automate I won't say very easily, but we can automate. And instead of you doing all of the work, we will work for you. So in Komodor, we started doing that by focusing again at the developers and trying to build a tool that is perfect for developers to use to troubleshoot, meaning taking them from a novice level into an expert mode using GenAI. And I think as time will progress, we will see more and more complex scenarios that are being handled by GenAI. In the end of the day, DevOps also don't want to troubleshoot like a very complex scenario. That's life, and it will be probably a bit harder to automate. But I think like that's the ambitious.
What do you think?
For me, Kubernetes is very good field to apply the GenAI, because Kubernetes requires a lot of knowledge. It's so many things, and the knowledge is one part of it. The second part of it is the amount of information that you need to deal with. And we know that the huge amounts of information are, humans don't like that. The machines are fine with processing the enormous information volumes, but humans are bad with it. So we have a really good combination when that brain that remembers whole internet, basically, that's the neural network behind the language. It's the network of remembering whatever it was trained on. So it remembers the whole internet. That's amazing. This is why I'm replacing Google with it. And then you're taking the volume of information that happens in Kubernetes, the complexity of relationship between objects there, all of that difficulty, and then it's really a place to apply that intelligence of language models. And I don't know how to overcome that complexity. And Kubernetes expands and evolves in such a dynamic way. I don't know how can we keep up at scale without offloading these intellectual tasks. This is interesting. We are now talking about offloading not manual and tedious tasks, but also intellectual tasks, but difficult tasks of you need to know a lot, plus you need to process a lot of information. And we are offloading that. So for me, this step that we're doing is very natural. Without this step, we would be stuck because there is limits of our squishy human brains and bodies of how much can we process in given time period.
Yeah. And
so this is the best to be short, this is the best place to apply AI, in my opinion.
yeah, especially given that Kubernetes environments are only growing and growing in scale and becoming more complicated. And a new version is coming out every 6 months or so. Definitely. So what do you think is the key to simplifying Kubernetes? Like what, where do you put your focus on? Is it simplifying the interface so you don't need to learn kubectl commands and you can just naturally speak with your terminal, or is it something else? Is it just eliminating toil, or where is the basically silver bullet, if it exists? If there's one area where you can target your AI agent to make it simple. And for the people asking for visuals back home, don't worry, we will soon dive into the architecture of Claudia and how it works. So bear with us.
Itiel, would you
No,
like to?
you go first this time.
I go first.
Yes.
So, in my opinion, the bad strategy would be to try to just keep processing all the information or address everything. The good system these days around Kubernetes, in my opinion, is not about eliminating kubectl. It's about eliminating the need to constantly look everywhere. You need to basically be event-driven. Something needs to happen that would attract your attention. So it's either the problem that is happening in your cluster or some sort of report is presented to you periodical or some based on some events that shows you the potential areas where you would apply your efforts. Just sitting in front of the computer, even if we take not kubectl, but Komodor platform. Komodor platform is still a way to present your clusters and all of those volumes of information. You don't want to go there just to observe, just in case anything bad happens. You would like to be notified. You would like to be presented with the top interest things in your cluster. I don't know, something that is really standing off, violating your standard, your internal standards, the industry standards, and misbehaving, consuming too much resources, costing you too much money, or offering you to save good amount of money if you would apply some resources. So these insights, when they are coming in to you at right moments, this is only when you start to be involved with Kubernetes. Otherwise, the amount of things to just go and look is not processable by human. So the ideal thing is when something detects the problems or areas of interest for you first, and then you involve AI or human, or you do something with it. So it always starts with something, some automation, finding the places for you human to look at or to act on. That's my take.
All right, so let's share some visuals.
And yeah, basically this is our vision, and the things that I've just said, they can be illustrated with this diagram, because one of the learnings that we have from implementing Claudia, experimenting a lot with it, and finding the right way to apply AI that worked really well for us, is that you do not start with AI. You start with something, some classical deterministic algorithms that you use to detect the areas of interest, detect the problems, detect the events that deserve to be investigated by human or by machine. And then you, of course, you don't want to spend human time, so you start to spend machine time. Claudia, you come to Claudia when the automation, the deterministic automation, has found something that is worth investigating. And then Claudia does deep investigation and does its thing.
So let's go through this diagram and explain.
Udi, do we have like a version that is like bigger, like in other slides, or?
Yeah.
I think let's put it, and I'll suggest I'll give it some segue. Like after all of this talk in Komodor, we did like bet quite a lot of resources on working on GenAI solution for Kubernetes. And we had a lot of like trial and errors in order to perfect it. And what we're going to show right now is the internal of how are we harnessing GenAI in order to help our users to solve issues in Kubernetes. Basically, for every kind of Kubernetes issue, for every time a pod is restarting for no apparent reason, your deploy just failed, your node is misbehaving, Komodor with Claudia, which is the name of the GenAI agent, will allow you to understand what happened and like hopefully help to find the root cause. We built Claudia in a way that is both like trustworthy and also in a way that explain to the user some of the evidence that led us to do what we're doing. And Andrei is now really going to talk about like the different mechanism, but this is the mechanism of Komodor GenAI that is designed to solve issues.
Okay, so once again, I will share a bigger view and I will zoom in as we continue with the flow. So let's start with the input.
So we want to describe the principle of how Claudia works.
Absolutely.
Okay, yeah. So that will be a short story because I mean, well, it happens quite quickly inside, but the stages, it goes through the stages. So first stage that is very crucial that we found is very good for the results quality is to not start in language model or to not try to apply AI with the broad task that many players on the market do that. They try to give really broad task definition, a lot of information, and say AI, please find whatever deserves to be investigated. While our approach is reverse of that. We use existing, this is something that we have in Komodor from the very beginning. We are able to detect the problems in the cluster, and that doesn't require intelligence. You can use pretty deterministic ways of doing that. But then once you narrow down to the specific workload or the pod sometimes, or the job, then it's much easier to explain the task to AI, what it needs to do. So we explain it that we are working in the context of this workload or Kubernetes resource, and that we want to investigate and find the problem, find the suggestions, and that we want to do that in a friendly, in the newbie-friendly manner. That is also important because we imply that in front of the computer, the consumer of the results of Claudia, he has less experience in Kubernetes, and overall Komodor platform simplifies Kubernetes for consumption. But I think we should, the more we democratize the technology, the easier it gets for people. And we see that among our customers, that it's really important angle, Kubernetes. So we started, we identified the task, we give it to Claudia, and then Claudia does its thing. As I said, this principle of giving it eyes and giving it hands, we are trying to apply that. successfully trying, in my opinion. When we let machine query the data, there is this reg pattern of using AI. We're using reg pattern, but we modify that reg pattern. So we make it iterative. It repeats. This is basically the right thing when you go and you repeat that pattern. After we have identified the problem, there is a small step, but that step is very simple when we direct the flow based on what is the area. Is it the workload of certain type? Is the context of the problem something that we know, I don't know, out of memory deserves its own investigation flow? After we chosen that big route or big model of investigation, then we do iterative RAG when machine consumes.
Can you explain how you choose what's the difference between the different models that Claudia can deploy?
It's very simple. We look at the attributes of the problem that we found in a deterministic way, and in Kubernetes, most of the problems they fall into like really handful of categories. And based on that, we're choosing just slight variation of the investigation flow that would happen. This is as simple as that. I would not pay too much attention to it because it's really small. It's important, but very small step in the process. The main thing is that RAG approach, when we leverage the Komodor's access to data and the sophisticated way we analyze and store the data from Kubernetes cluster, so we can present language model with that data, and that drives the quality, that increases the quality of its conclusions because it has really good input information. One thing that I learned working on it, is that the data is basically everything. You cannot change, you cannot do much with the language model. And when you're doing these automated things, your prompts, they are kind of frozen. You can't vary them too much because you want the predictability in results. So basically the difference becomes which data do you bring to it. And here we do the iterative RAG approach when the machine helps us to understand which piece of data to bring in next. This is something that you would see if you would use Claudia on the screen. It would show you the steps, how it proceeds with this investigation. For example, you're asking to investigate the deployment. It would start, let's say, to see the status of it. It would query the YAML or describe of this deployment. Then it would choose the unhealthy pod in the deployment. It would look at its events. Then on the next iteration, it would look for its logs. Maybe then it would, in the logs, would see that the config map is involved. It would start querying config map. And basically, it can go anywhere in the Kubernetes cluster. This is why it's so good and so powerful. It's not limited by the really narrow scope. It goes wherever it can, wherever it needs to find that information. And all of that information accumulates in the context of language model. So with each step, it gets closer and closer to conclusion of the root cause, eventually gets to it, and then we present that as a result. We are doing some additional, how to say that, clarification on its conclusions to make sure that the result is final, and then we present the results to the user. It takes a bit of time. You can hear me explaining the steps, and you can imagine that it takes a bit of time. But only then, after spending this time, after accumulating the context, we get to the really good quality of results. I'm a skeptic, but when I built this thing, I was impressed by the early experiments, how good it is in its conclusions. It's basically varying from, okay, it's kind of obvious problem, so you give obvious and good result to the amazing, because I, with my experience, would not go to check for the config map change recently and explain me, please revert the config map because previous version was good and you introduced the problem by referencing or modifying it. That's really cool, and that's only possible because of this iterative process that you see on the screen.
So let's just quickly recap what we covered. So we have Komodor, a Kubernetes platform that can detect any issues, and in this case, it detected a failed pod deployment. Then it chooses the correct
it goes to the
model, right?
pod deployment problem sub path.
Yeah, and then deploys this specific model for the specific issue. Then it engages with the RAG model, which has 4 layers of data, or probably more, but the 4 main ones, which is...
Let me correct you. The RAG is the whole process, iterative RAG. It's like many RAGs executed, and this is the Komodor's layer of data. This is the main source of meaningfulness of that model. So it interacts, the language model interacts with Komodor data back and forth until it reaches the conclusion.
And the cool thing is that when does it know that it has reached the conclusion?
I will not tell you that because that's a bit of a secret thing, but there is a way for us to understand when we need to stop the RAG. We have our way to define to language model let's call it the stop signal. It knows when the stop word, you know. we tell it, yes, once you are confident, please say the stop word, and it says the stop word and we stop.
So yeah, just to abstract away our IP, we are talking about a confidence meter that keeps growing the more the Claudia is confident, correct?
Correct.
And for people who can't see, as Andrei describes it, Claudia is doing what a good SRE would do. So
exactly.
Is this correct? It's scanning the container logs, then it's analyzing the pod logs, then it's identifying.
Here's the good SRE going and doing. Basically, if you work as SRE and you know how your issue investigation looks like, it's you spending this time. This is what human would do. Human would go and read the logs. Human would go and read the YAML. But I'm sorry if your YAML is 50, I don't know, or 1,000 lines long, and we're seeing these YAMLs. We know that this is real, and the comfort of that thing doing it for you, just the automation of that is amazing, and this is why it's so cool and why it saves time. Human can do all of that if human has the expertise, but behind this thing there, you can think of the whole internet learned into this model. This is why it's so cool. It really replaces the SRE.
Well, that's not scare away all the SREs at home.
I want to deep dive into like one of the points and also maybe answer some of the questions here. How are we compared to other product, or how is it different from, and I'll do like answer live, and I'll do another one, answer live, yeah.
And
yeah.
So Itiel, just before you answer the question, I just want to show the output, the end, and this
I'll do a live demo, no?
Yeah. Oh yeah, I'm just showing that once we have the root cause detected with confidence, then Claudia will deliver remediation instructions and will present the evidence of why it has reached that conclusion. And this is something that I also think is pretty unique, and also that the model keeps learning. So we resolved an issue here, right? We resolved an issue, and next time Claudia will know. It will learn from this experience and from this root cause analysis. And yeah, okay. Back to the questions, yeah.
And so there were like a couple of questions here regarding how are we different from just sending all of the logs to Splunk? or how do we compare it to other tools? So I think like those are great questions. Like at the end of the day, if you already have all of the data in Splunk, why can't I just use some anomaly detection? And again, I think this drives like the core of what Andrei said, that we're trying to replicate a good SRE, right? And in Splunk, you will see, for example, a log, application is crashing, exit code 1, I don't know, missing a variable, or a variable is misconfigured. But a good SRE will now go to Kubernetes, he will use like K8s, right? You will see the pods, you will see the YAML, you will see the config map, the secret, maybe Vault. You will do a lot of different things that are not part of the logs. Cloudia and Komodor in general, our view of the world is that you need all of this data on one hand. You need the ability to view the config map. You need the ability to view the YAMLs, the raw event, and so on. But on the other hand, you don't want all of this data to begin with, because then you will simply be confused. Like you'll have terabytes and terabytes of data. So our approach is to start very lean, start with a very simple problem, and then give Cloudia the muscle, basically, we use in our RAG, in order to fetch more data points that simply doesn't exist in other tools. And also the way that we're doing that is not throwing all of the data on the model, because this doesn't work. But instead, we are, like Andrei said, like an iterative process that is able to understand what data is needed and then to fetch it on demand. So this is a bit on us basis, maybe like Splunk or like Splunk anomaly detection. And there's like a raise of hand. Nikki, what do I do when someone raised the hand? Or Udi? I don't know. I don't know. I'm not. Sunita will get back to you in a second. I will also say that there was a question: how does Komodor compare to BMC Helix? I'll be honest here, and I'll say I don't know. We did a comparison with like the best-in-class solutions by Google, like the GenAI open source project, which is great, Datadog as well, Dynatrace, and I can say that Komodor is something like 10x better than any other solution when it comes to solving Kubernetes-related problems. That means that our answers are better. We don't hallucinate, and we're able to provide relevant evidence. And we have a full playground with around 30 different scenarios that we keep on testing. We're testing like us compared to other vendors, and also we're keep on experimenting with Cloudia itself. Like we're releasing new versions on a weekly basis of how does the actual code looks like and work on the prompts and the data. So given this, I don't know, like you are saying that BMC Helix is something similar. That is interesting point, and we will like add it to the to our comparison metrics. But from what we saw, like no one in the industry is even close to the same level. When it comes to doing like forecasting, I think like it's something super interesting, capacity forecasting. But Komodor is not like doing that at the moment, and Cloudia is also not doing that. So that might be a great feature that we're not doing. So yeah.
And we'll touch on the vision for the future and potential roadmap.
Udi has the plan.
But first, Itiel, do you want to show Cloudia in action so people will see that it's real?
I think it's a good time to just demonstrate what.
Yeah. I'm going to demo the product. There was a question here regarding the logs. Where are we fetching the logs? We are fetching the logs from within the cluster. If your logs are stored somewhere else, for example, there are no logs in the cluster and they're all being routed to AWS CloudTrail or Splunk, we're also able to fetch the data from there. But our native and core integration is directly from Kubernetes, fetching all of the data on demand when the issue happens. We are not a log analysis solution. We don't have all of the logs. We don't care about all of the logs. We take a very small snapshot of the relevant logs for that specific issue and problem. So with that, let's do like a very quick demo, and I'll try to demonstrate maybe like the value of how Cloudia is working. So I'm going to do here like a share, and this is the Komodor platform, and right, like everyone able to see it. Yes, Udi?
Yes.
You are not saying anything. So we're able to see here like the Komodor platform, and I'm not going to dwell into the platform and all of our like capabilities regarding how are you able to see all of the different clusters and their state and their reliability and issues over time. I am going to focus more around Claudia. And Claudia works every time Komodor detects that there is a problem, that there is an issue with your system. And I will give first of all, an example around a service that is currently unhealthy. This is a Kubernetes workload. In Komodor, you're able to see not only the current state of your workload, but all of the history. We have some sort of a time machine for your system, meaning you can go back in time and understand what happened to the system, how did it change, and so on. In the example that we're seeing here, by the way, you're also seeing events from PagerDuty and Datadog. But more importantly, I can see that there was a successful deployment and then a failed deployment. Once I click on the failed deployment, I'm able to see a full analysis because I already did this demonstration, a full demonstration of how Claudia gives you the analysis. So just let's take a step back. We're in a workload in Komodor, you're able to see the deploy. And as part of this deploy, you are able to see different logs. You are able to see all of the things that change as part of the deployment, like different config map changes, GitHub changes, and so on. Claudia is now here to help us to solve the problem. So it tells us what happened. Basically, an API rate limit misconfiguration causing health check failures. So the deployment don't have all of the replicas available. Font condition shows some ready issues. Inside the logs, those logs basically, Claudia detected there's a problem with the API rate limit. Then it went to the config map, it checked what is the value in the config map, and it told us, hey, you need to change this value in here, basically the API rate limit, which is this variable right here. So Claudia did for us all of the analysis. Basically, it took a very complex problem and simplified it. This is already issue or incident that I already view. We can also go to one of the unhealthy pods here and do a full investigation live. This is basically Claudia is now starting the investigation process. So we can see here that we are analyzing the YAMLs, right? And Claudia is explaining to the user what is she doing. So she viewing the YAML, and then she's fetching the events, and now she's fetching the relevant logs from the container, and now it's fetching the relevant config map, right? You can actually see the brain of Claudia in a way in its work, and it tries to figure out what is the root cause, what happened, what are the evidence. So now it is finalizing the conclusion, and we can see here again, reduce the value of the API rate limit, which is the actual problem in the system. And you should change the config map in order to solve it. So I'm going to stop for a second and just let you imagine. We can have more examples here, but think about a tool that every time that you're having a problem is taking years of experience, and also basically, like Andrei said, all of the internet, and tries to help you to solve that issues as quickly as possible. And it is true if you're a Kubernetes expert, and it is even more true if you're a developer who is not necessarily a Kubernetes expert, but his pod is crashing in the middle of the night. So our vision and our product aims to simplify every kind of Kubernetes problem, every kind of Kubernetes issue that the users can experience. And it is true also for node issues. I think all of the nodes are currently healthy, for pods, for jobs, for shared manager failures, external DNS failures, Istio failures. We want to simplify troubleshooting and to do a revolution basically in how issues are being handled inside of Kubernetes. With that, Udi, anything else that I missed here, or Andrei?
No, it was a good demonstration. I hope everyone noticed that when we gave basically the same language model, two different routes on the same problem. One was from deployment and one from pods, but the model is such a flexible, not the model, but Claudia with the model. It's such a flexible thing that it came to the same conclusions by two different routes, but it quickly settled on the same root cause, and the result is the same. It may be not so obvious for somebody who just sees two similar results. For me, how I know that it's actually goes slightly different routes and coming to the same conclusion, it's actually very nice, and it proves that this thing is not deterministic and rigid. It's very flexible, and that's cool. This means that next time there will be different problem, and it would react and adapt to that problem and would speak the language of that problem, as opposed to very strict rails of something deterministic. That's the best thing.
Yeah, and I also want to highlight a couple of things. So we just saw Claudia doing the thinking in real time, and it took about how much? 10 seconds, 15 seconds?
15, 20. The average 15,
20 seconds. And Itiel, you've been a DevOps engineer for many years. What do you think of this benchmark? Is this
I think for most use cases, 20 seconds is only to find the right context, like the right kubectl context, and to log into the relevant cluster. Like, I think that is the reality.
When we were starting to develop Claudia, the investigation time was around a minute. And I was telling everyone that, hey, it's already cool, because instead of digging through multiple things on the platform, what SRE would do, he would just go grab coffee and return to see that machine already went to different places, collected information, analyzed it, and SRE basically is given the remediation steps or the root cause of the problem. But now when we optimized that and made it to be 15, 20 seconds, you cannot grab coffee anymore.
You ruined it, and
yeah, I ruined that story. So now you basically maybe have a small chat of couple of things with your friend and back to work.
Yeah, it's not. We need to give a bit more buffer.
Times.
Yeah, the people.
I want to answer Subesh comments on the structural searching mechanism, starting from container logs to pods logs. Like, Claudia will give different searching algorithms, or it will ask for different data points based on the data that she observed, like different events, even different namespaces or different containers will lead it to different result. Like, it's not deterministic. I don't have any idea what will be Claudia next step. Usually it's the next logical step, but it's not.
It would go to node level. If it sees the problem with scheduling pod, it would ask to give me the node information, and it would tell you that the node is having pressure or whatever. So there is big flexibility that is put in there. It's basically limited by only types of information, but not specific information that it would get. It's unpredictable sometimes,
but reliable.
Yeah, because we're doing this iterative confidence boosting. It's at the end, it's reliable. It may spend sometimes more time investigating if it doesn't find the problem after these data and after that data, and maybe there's no logs for the container at that moment. So it would go different, more extended investigation. And at the end of the day, I only saw a couple of times when results are bad, and usually the results are bad when it couldn't find information. Very rare occasions when there's no information. Then it gets funny sometimes with language models because they start to hallucinate. But I was afraid of hallucinations in the beginning a lot. I was really afraid of that because I used to train neural networks, and I know that these things, they always work. They will not tell you, I don't know. They will just generate whatever output you want from it. And if it lacks the inputs, if it lacks the facts, it would invent the facts for you. And this is not something that you want in your job, that the machine would invent the facts. So it's good that it goes into such many places and gets so much information, because this is what makes it confident.
Yeah, people pleasing is never a good trait, not with humans and not with AI models. And another thing I wanted to highlight in Itiel's demo is that it not only pinpointed the correct root cause and told you exactly what to change in which config map file, but it also gave you a link to the specific one, and you just need to click on it and change the API rate limit directly from the Komodor platform, which is even more streamlined and easy and simple.
This is the hands I was talking about, because that thing, the text that language model outputs, it's still not enough to be really useful. It's okay if you have a smart friend that tells you what to do all the time, but at some moment you would tell him, go do it yourself. I'm tired of your advices. So this is what everyone should do in the industry. We need to make applications of these outputs of language models. And it should not be just the text. It should be integration into Komodor platform, in our case, in sophisticated platform that does very different things and solves problem and gets you as close to the action of solving the problem as possible, but still it expects you to review because it's important, can be dangerous sometimes to be blindly applying things. So we are not trying to do auto-fixing and auto-healing because we know that the mistake there could cost you millions sometimes. We don't do that. We appreciate the business of our customers, but just don't spit out the chat messages at humans. That is rough. That takes too much time to read. Everyone hates to read those long outputs of ChatGPT explaining everything and how good that you asked it. It's a waste of time for me. Let's be closer. Let's be more active.
Yeah, Udi, we have like 3 more minutes, so I think it's like right. So I think it's
we have one final question, but before we answer it, I want to ask you both, what is your vision or dream? No commitment here, just dreams. Where do you see Claudia going, or where do you see AI in Kubernetes going in general?
Solve as many problems as we can and give relevant remediation. I think like the world of Kubernetes troubleshooting is so vast, and we just started to poke around like the edges of it. And I think that if we're able, first of all, to have better like detection, investigation, and then remediation, like that's the dream, right? Like someone else doing the hard work for you. So that's me.
Andrei?
For me as a developer, I would love to apply this principle of turning language model into active actor as opposed as just a chatbot. So, and applying it in more situations and more use cases, because Claudia, I love it. Right now it resolves pretty similar use case and similar conditions. It works great, but I would like to build something bigger that would address some bigger problems. Maybe those ideas from our viewers about analyzing capacity planning or something like that. Sky is the limit. I see that there is a lot of power in this thing. Internet of knowledge, ability to reason close to human brain, in given right information and right instructions, hands and eyes. That's cool. I would love to apply it to more problems in Kubernetes. And maybe, who knows, one day we will get to that place when we are not only detecting the problem and then giving it to the machine, but actually giving the machine a lot of freedom. The more I work with it, the more I see that the usage patterns of language model can be really not obvious, not the ways we think of it right now. So we can get to that place at some moment, I think. More use cases, more different use cases, more various scenarios, not only troubleshooting. This is my vision of the future in Kubernetes specifically.
Sounds like the future is bright for Kubernetes and AI. And let's see if this next question gives you another idea for the future. Does it have a feature to generate alerts and remediation scripts when there is an issue with a network policy or communication with pods in a namespace?
Isn't
we will be
this core past feature of Komodor? It's like we are having these kind of detections for quite a while. Itiel?
Yeah, no, like again, like the Claudia will do only the investigation when it comes or recommendation. Komodor will do alerting for that scenarios, and there's no like creating of a playbook for different scenarios. it is something that we're looking at, but again, like Claudia is doing investigation only, while the rest of Komodor is doing the detection, the actual remediation inside the system.
Yeah, we already have these detection and notification features in our platform. It's just that we are now attaching Claudia, that the content of that investigation will be much more digested, ready to act on. And somebody already walked around the system and got the information and understood what is important and what is not. So basically, this is what changes now in Komodor.
So we covered the present, the future, and now the past. And I think this is a good place to end this event. Once again, everything that we discussed for the folks back home, all those principles, the diagram that we shared, all of those principles can be applied to other models. Those are things you can learn and use everywhere. It's not just to explain how Claudia works, but GenAI in general, and kind of open your mind to different possibilities and potential application.
We said cloud eating the world, or whatever eating the world. AI is eating the world actively right now. It's there, and it's me, skeptical me, talking about it in such an optimistic fashion. So it's really there. Let's see how can we apply it in our lives, in our products. And I encourage everyone to just start doing that and not just chat with that thing for fun. Build the application on top of it.
Yeah, and Claudia is available. Once you try a Komodor self-serve, it will work out of the box for you. So it will start to work seconds after first installation.
Yep, and we have a 14-day free trial, so you can go on our website and check it out for yourself. See Claudia, see the other more extensive platform features, and if you like it, you can talk to us. So thanks again, Andrei, Itiel, for showcasing Claudia, and thank you for the hard work building Claudia. And Nikki, thank you for setting everything up, and for the folks back home, thank you for joining us, and we will share the recording and the deck with all of you. So until next time, thank you for joining, and see you around.
Thank you. Bye.
Bye.
Bye bye.